So we're going to look at how to write Kp. Now, all along we've been dealing with Kc, and actually in the later chapters we're mostly going to be dealing with Kcs. They might be specific types of Kcs, but they are concentration-based K values. It's concentration-based. This one is a pressure-based value. So when we set up our Kc, remember it's products of reactants and they're raised to their coefficients. So this is NO2 raised to 2, and then N2O4. For the Kp, you set it up exactly the same, except you use P's instead of concentration units. So you would say P of NO2 squared. So I don't know if you like having a parentheses there or not. And then P of N2O4. So you're identifying which pressure you're talking about. And when you're solving these values are going to be given to you in ATMs. So can you convert between? You can convert between. So if you were given that this value was 30.1, and again, that'd be given to you, or you'd be given the information for these two so that you could calculate it. But if you're given that information, you can actually take it and you can turn it into Kp value. You can also be given these pressure values, and you can turn them, you can solve for Kp, and then you can turn it back into the Kc value. So there is a relationship between pressure and concentration, and you probably should have remembered that, because remember PV over nRT, and if you remember P is equal to moles over volume times RT. So that's molarity, and that's your pressure. So there's a relationship between the two of them, and that's what we're taking advantage of. So for Kp over here, if I'm solving for Kp, I'm going to plug in my Kc, which is 30.1. That, again, that would have been given, or you'd had to figure it out some way. The R value used in these is 0.0821 liters, ATM, moles, Kelvin. And then your T value, I actually don't want to close that yet. That value is going to be in Kelvin. And let's say that this value here was 25 degrees Celsius. That's not going to be the right value, but let's just say it is the 25 degrees Celsius value. Well, you're going to need to make sure that you put it in Kelvin. And then the whole thing is raised to delta N. Now, N is all of your products minus reactants. It's the moles of them. So just use the coefficients to help you here. So we're going to look back up here, and I have 2 moles of this one, and I have an understood 1 mole of this one. So my delta N is 2 minus 1. And when I plug that into a calculator, 30.1 times parentheses 0.0821 times parentheses 25 plus 273.15 parentheses closed, raised to the 2 minus 1. Oops. Sometimes your calculator doesn't work with you. And then that gives me that my Kp value is 736.8. And since the majority of this looks like this is all going to be rounded to 3 sig figs. So we'll make that 737. Kp, like Kc, is unitless. And just keep in mind that your delta N, it could be positive, it could be negative. If you had equation, if this equation had been written opposite, whereas NO2 going back and forth to N2O4, well, then your products are 1, and so it would have been 1 minus 2. So it's okay if that turns out to be a negative number. That's totally fine.